Hello everybody and welcome. This video we are talking about what is a limit and what does a limit tell us. The answer to these two questions are sort of intertwined. So basically by understanding what a limit is telling you, you can then understand what a limit is. So here I have this expression written down, limit as x approaches 3 of f of x. And, there's nothing special about x equal 3. I just kind of chose 3. And this cursive LIM, what this means is, it means don't tell me what's happening at 3. It's saying what is happening in the immediate vicinity. And I have immediate vicinity underlined here. What is happening in the immediate vicinity of x equal 3? On the function f, right? So what is the behavior of f in the immediate vicinity of x equal 3? And we're going to talk about what we mean by immediate vicinity here in just a moment. Okay, and I've already kind of told you this, but it does not tell us what's happening at x equal 3. That's what f of 3 is for. F of 3 tells you exactly what is happening at x equal 3. Okay, and the limit as x approaches 3 does not have to be the same as f of 3. In fact, they have nothing to do with each other. I'm going to say that one more time because it's important. The limit and its existence and whatever its value is has absolutely nothing to do with f of 3. They're completely different things. F of 3 tells you what is happening at 3, and it tells you nothing else. And the limit tells you what is happening immediately surrounding 3. So in other words, immediately to the left of 3 and immediately to the right of 3, if we're talking about just a regular curve in the xy plane. Okay? So that's just sort of a quick background. Let's see, we don't need this right now. Don't worry about that. Maybe I should erase it, yeah? Let's erase it since we don't need it. So now that, we sort of have a vague idea of what's happening, let's look at some graphs so that we can really understand what's going on. Okay, so here we go. Let's look at a few situations. First, okay, little XY plane. And let's look, let's see, 1, 2, 3, right? First, let's look at this little situation. Okay, and what I'm going to do is I'm actually going to put a little hole here, yeah? So right here, and this is x equal 3, by the way. So here's the point. By putting the hole here, immediately f of 3 is undefined. There's no function there to speak of. Okay? And just for simplicity's sake, let's say this is y equals 1. Okay, so in other words, the whole location, the whole is located at x equal 3, y equals 1. That's where the whole is. Okay, so I want to emphasize this, f of 3 is undefined. Okay, however, we can say something about this, the limit as x approaches 3 of this function. And there's only two things we have to consider, okay? And this is for any limit in the world on a curve in the xy plane. Okay. We look at this. We look at the left-hand limit, which we write this way. And then we look at the right-hand limit, which we write this way. Okay, so the way that we read this is the limit as x approaches 3 from the left of the function f. And then here on the right, this says the limit as x approaches 3 from the right of f of x. Okay? And so let's discuss these one at a time. First, let's talk about the left-hand limit. So what it means to figure out a left-hand limit is the following. All you have to do is think about the x value in question, 3. Oops, didn't mean to do that. Here's x equal 3. I'm gonna locate my graph, and there's a hole. It doesn't matter. I'm gonna go immediately to the left of 3. Immediately to the left. So I'm gonna go here, and I'm gonna sketch toward 3. Okay, this is what limits are all about, is getting really, really close to the x value in question from the left and from the right, and seeing if you notice any patterns. And look at how close I'm getting, right? Like, we really can't even see the space between x equal 3 and these little sketch marks that I'm putting. And that's how close we need to be thinking, right? X equal 2, not close enough. X equal 2.5, not close enough. I'm talking x equal 2.999999999, right? And the idea is that you can keep adding 9s. You can keep getting closer and closer and closer to 3 without touching it. This is an artifact of just how real numbers are put together. There's no upper cap on the number of digits after the decimal place that you can use to get to not get any closer to 3 without touching it. And the same is true for the right-hand limit, right? So if x equal 3 from the right, boom, this one, here's 3. I'm going to go immediately to the right, and I want to sketch closer to that. Okay, and we're back. So, as I sketch closer and closer and closer, again, that's what the limit's all about. So, as we can see visually with the blue sketch marks and the red sketch marks, we are getting closer to the y value 1. Okay? So again, f is undefined at 3, but this limit is 1, this limit is 1, because that is the y value that we're getting closer to as x gets closer to 3 from either direction. Okay? So there's that situation. Let's look at a different situation. There's that, x, y. Now let's look at this situation here. Not what I meant to do. these are supposed to be the same point here. Once again, let's say this is x equal 3. Just to keep things simple, right? So this is 3, then we'll have 2 here, and, you know, I don't know, 1 would be about here, something like that. So, okay, and then also let's do 1, 2, 3, like that, okay? So now, you know, here's the thing. Here, let's think about f of 3 first, right? F of 3 is not the whole, it's what's filled in here. So the y value here clearly is 0. Okay, so f is defined. Good. All right. How does that compare with our limits, right? So once again, to figure out the limit, to figure this out, we need the left and right hand limit. Okay, so let's think about the left hand limit first. All right. So x equal 3, and go to the left. If we're left, we're here. We're on this part of the function. And if I sketch toward x equal 3, what y value am I getting closer to? 1, 2, it happens to be 3. Left-hand limit, we're getting closer to 3. Now, what about the right-hand limit? I'm just going to go to keep it blue. Okay, well, here's 3. If I go to the right, I'm on this part of the function. So if I sketch toward x equal 3, and remember, you know, think about doing this forever, right? 3.1, 3.01, 3.001, 3.000000001, right? There's no limit to the number of zeros we can put between the 3 and the 1. So as we get closer and closer and closer and closer to 3 from the right, the y value is getting closer and closer and closer and closer to, 0. Okay? So in this case, the left-hand limit and right-hand limit are not the same. Okay? These two things, these two expressions are not the same. They don't equal each other. So the limit, as x approaches 3, of f of x does not exist. Okay? So for a limit to exist, the left and right hand limits must be the same, and you know, the limit just means you sketch immediately from the left to the, you know, closer and closer to the x value in question, what's happening to the y value. And then for the right hand limit, we do the same thing, but from the right hand side. Okay, good. So anytime these left and right hand limits are not the same, your limit doesn't exist. Plain and simple. There's nothing else to discuss in that regard. One more thing. One more situation, and we will be finished with this video. Let's look at this situation. We're going to infinity that direction. We're going to infinity this direction. Then we're going to go negative infinity here, positive infinity here, positive infinity here, and then negative infinity here. Okay. Now let's say this location, let's just say this is x equal 1. Let's just say this is x equal 2. Nothing crazy. And let's say this is x equal negative 1. Okay. So due to the asymptotes, f is undefined. At x equal negative 1, 1, and 2. Let's look at the limit as x approaches negative 1. Okay, well, if we look at the left-hand limit, if we sketch from the left, here we are, boom. And if we sketch closer and closer and closer and closer to x equal -1, we're going to infinity, positive infinity. The limit as x approaches -1 from the right, f of x, well, once again, from the right, we're going to sketch closer to -1. Y is going to positive infinity. Okay, so this means that both sides of the function are going to the same place. And normally we would say that the limit exists and is equal to positive infinity. But here's the problem. Infinity is not a real number, right? I'm here at the bottom of the screen now. Infinity is not an element of the real numbers. Okay? So this, these limits, they tell us something about f. It tells us that f is going to infinity, to the left and to the right of x equal -1. But since infinity is not real, it's not a real number, we cannot point to exactly where this thing is going. This is going to keep going up and up and up and up and up and up forever. And so we still say that this limit does not exist. Again, because infinity is not real. Okay? If we turn our attention to x equal, I want to kind of speed up a little bit here. If we turn our attention to x equal 1, this is, by the way, this is supposed to be to the left of x equal 1. I kind of went a little too far there. But as we go -1 from the left, we're going to negative infinity and then positive infinity. So we have two different infinities going on, also not going to exist. But left-hand limit, negative infinity, right-hand limit, positive infinity, without a question. X equal 2 is the opposite situation. Left-hand limit, positive infinity. Right-hand limit, negative infinities. And that one doesn't exist either. I mainly wanted to talk about this case here, where they're both going to positive infinity. The limit still does not exist. Okay? So that basically covers it, right? We've seen a situation here where f is undefined, but the limit is perfectly defined. We have a situation here where f is perfectly defined, but the limit doesn't exist. And then we have these infinity situations where, we still learn what the limit is. Oh, and by the way, one last thing. Even if you write this, okay, this is correct. This is correct. But the thing that you have to understand is that this is still not real. Okay? So this is a more this is a more descriptive version of does not exist. Okay, it's like, okay, the limit doesn't exist. Well, what do you mean? Well, they're going to infinity from both sides. That's why it doesn't exist. So even if you see this, and you will, that the limit equals infinity, it's true. We're going to infinity from both sides. But it's also true that infinity is not a real number. So again, this is a more descriptive version of the limit doesn't exist. And